Mia says is not going to join, come anything. She's but
You should wait.
no Mia saying.
Yeah. Wasn't able to come, I think.
Got the draft.
Yeah.
Okay. We are going to take over.
Someone take over.
Someone will take over.
She still keep the
Yes, student.
yeah.
Okay, PhD.
Yeah.
Should we get started?
Yep.
Yep. Okay. Okay, maybe we can get started, folks. Welcome to the DMM working group, IETF 120. I'm Srikanth Valley, Cisco.
Satoru Matsushima from SoftBank.
Okay, first thing, please be aware of the IETF's IPR policy. Please read the respective documents. There's a notable statement. Please go through this, be familiar with the IETF operating rules. I think we need a note taker. Anyone volunteer?
I can do it, but I never done it before. So
Okay, maybe it's a good way to start, right? Maybe if you can, yeah, if you can try.
There's a button on the agenda. I saw the note taker something there, right? I click and then it's added.
Yeah.
Okay, I'll try. I don't know whether I can catch it, but I think the auto machine is going
Okay.
to catch most of them.
Sure. Thank you. Thank you for that. So we have two working group documents. One is the mobility aware transport network slicing for 5G, and then is the architectural discussion on the survey 6 for mobile user plane. I think on the first one, Satoru-san, you have anything to comment on the mobility aware?
Yeah, we have asked to adopt, to have a working group last call for TNR aware mobility. I think we can discuss for that, and then whether we move forward to next step with from the author presentation.
Yeah. Okay, so with that, this is what we have on the agenda. You have any comments, questions? I think, okay. If not, maybe we can get started with John's.
We have a late submission for
there's one
agenda,
more,
one more
sorry.
end mark from Jeffrey.
Yeah. Okay, with that, John, would you be able to give an update on? Yep.
Should I ask for the slides?
I can share slides.
share.
You can share? Oh, okay.
I don't know.
Okay. Let me just ask you. Yeah. Ask to share. What should I do? How do I authorize?
You want to try?
It's loading, I think.
No.
Try again, John. Okay.
That's okay.
Asked to share the slides, but it's not giving me approval. Oh, okay. 1 second, here on the top. Okay, okay, sure.
Just a quick question. I do not see the auto catch up for the meeting. I thought going to have the auto catch up. No.
What is the question, sir?
Normally, you're going to have some the meeting minutes auto catch up over there, plus some auto machine.
Oh, the auto transcription.
Yeah, auto transcription. Yeah. No, it does not have. Okay, it's fine. Because this I try to do something, but I try to do.
Okay, don't worry, whatever you can capture. Yeah, it's fine. Yeah.
Okay, so this is the mobile aware transport network slicing for 5G. Um, just an update actually, because this time we did not have any specific comments. So I'll just go ahead and give you the status from the last time, and also how we could maybe make progress in the draft. So at the moment, as I said, that we haven't made specific changes because what was requested by the working group in terms of comments and everything has been addressed. Let me just quickly walk through that. I think the main comment was to remove sections that were talking about PPR. This draft has been simplified to not include all of those. Then there are some other sections that don't need updates. For example, the questions about source mapping for slicing. And if I go to the third point, I mean, it's the need to work with the transport side. Again, no updates needed there. Um, the questions on control plane and others have already been addressed, and I'll just quickly go through that in the next set of slides. Control plane and the private network part. So just again, a quick walkthrough of what has been done, and I'll also highlight how we may be able to proceed with this draft without too much linkage to the T's draft. So just a very quick overview of the main points in this draft, or what this draft is mainly covering, is how to do that IP transport. I mean, carry the IP, the slides in the IP transport such that it is useful in this whole framework that 3GPP uses. So this is not 3GPP work, but this is how to do the transport slides part that connects different entities in like a user plane function or a G-node B or other control plane functions that are separated by an IP transport network. Um, just so that this makes more sense, I think the structure is that you have different communication service that's highlighted on the very top of the figure. Those communication service may be served by a slice like slice A, B, which have in 3GPP and NSSAI marked with it. And then within that in that you may have one or more slice instances, which is the NSSI. Sorry, it's a lot of acronyms. I didn't create them, but they're there. Um, and if you notice, I'll go with the thread of communication service B, slice B, and the NSSAI 000B, and the segment below that, the slice instance below that. And in the next slide, I'm showing how this is getting at that segment on slice B, how this is getting mapped when the G-node BCU on the very left of this figure, top figure, is going to send a packet, a GTP packet to the UPF on the very right. And you can see this configuration NSSIB, this is an AN network 2. The details of the slice mapping are then mapped to the IP packet. In this case, we're specifically talking about using UDP source port mapping. And the reason for that, you can see in the segment between the G-node BCU and the UPF, you see there's a data center network, and that data center network has no slice mapping. In T's terminology, this is an attachment circuit. So this is the specific case that this draft is addressing. And the other techniques that are used that Tees is now elaborating on in another draft is talking about VLAN, MPLS, SRv6, all of which need an attachment circuit that is not, I mean, that is proximate to the G-node B or the other 3GPP entities. So this is specifically what we're going to talk about. And I think, in discussions this week with some of the T's authors, I've discussed that we can, keep this draft and the other one separate because of this difference, and not have a dependency, as I say, right? They're just related, different techniques, a bunch of techniques that are used when the attachment circuit is proximate, and this is an option when the attachment circuit is not proximate. Um, so that's a quick overview. Yeah, these are just showing the updates for the control plane and private network slices. I mean, this has been shown before, but if any of you have questions, I'd be very happy to go over the details. Again, removal of PPR, showing status of the network. As I mentioned, the aim is now to make clear about that attachment circuit and where this draft falls and what the other drafts in T's do. And so they become complementary set of mechanisms. And I think once we've made those changes, I'll look for reviews and updates, and then we should be able to proceed. That's all I have. Thank you. Questions?
Please. Yeah. It's okay. You can. Yeah. Okay. Yeah.
Can you go back to the DC, that thing, try to just to differentiate? I think you mentioned about the teeth work. I think there is a draft about the realization of network slicing for 5GS using IP and MPLS. So did you just talk about it during your presentation about the difference?
Yeah, I mean, if you see here, I have no way to point, but if you look at the box at the left, you can see that, oh, I have a point. Thank you. Well, let me just walk up here. So if you look over here, the logic interface ID and details like the UDP source port, the interface type is a UDP source port, and the interface is the value of that port. So that would be the difference between the others. Over there, it would be showing something like MPLS or SR or VLAN, and then the appropriate mapping. But all of those mappings would require that, there is no attachment circuit that doesn't carry, this kind of.
Thank you.
Thanks.
The questions. Right.
Eric Klein, just want to make sure that, are we going to CC T's on last call or send email to T's chairs? Do we need to coordinate with T's in any way? Or will they, I can CC them on when we go to IETF last call. Or you can CC them on the working group at last call.
There
Or
was
talk
some
to the
noise,
chairs.
Sorry, I could not hear everything that you said.
Oh, sorry, I was wondering about coordination with T's working group.
Yeah, I think before we forward the work, we'll get feedback from the other groups.
I heard that something, someone asked the review for T's working group, but I haven't heard of the exact feedback from the T's working group regarding this draft. But I'm a little bit concerned about the relationship being made on the between those and the working group. So I think it'll be okay, but we can ask the other working group.
I'll take that as an
Or,
action
what
for me and post the presence of this kind of draft and the progress we're making in DMM into T's, so that they're aware of it, and then maybe even present if needed.
Even we have the AI to run it with the chairs. Then also, both. I think if you guys can also. Sorry. Eric.
Thank you, John.
Thank you.
Okay. Any other questions, comments?
So I found the other draft mention about the mobility-aware transport in the RTG working group. So do you know that, or what's the relation between the transport-aware mobility draft?
Okay, that's a good question. There is a very loose relationship in terms of only the technique of using UDP source port, but that work is really talking about the N6 network, So if you wanted to, use a slice outside of 3GPP, so N6 really, then they're suggesting that there is a way to do that using the techniques that are in the draft. So that's really not anything that 3GPP should be concerned about, but it is of IETF concern. The technique is the same.
Understand. Thank you.
So John, this question came up multiple times, right? Mobility aware, the difference on mobility aware transport, transport aware mobility, right? Can we put some text in the, because this, I think, as far as I remember, this is the third time this question came up, right? Can we do some, insert some text into the document and say how it's different? Because this won't go away. Even ISG
Okay.
will come back. What can we do?
Just to understand the question, so it's the other draft in routing, which is mobility versus this one. Okay, I will take that as an action. Thank you.
I think we can ask the working group Rascal if we see the reasonable.
I think it's reasonable. Yeah,
Okay.
yeah, definitely we can.
Okay.
But we need to make sure that is overall, we don't want any let us say that no, you guys are redefining everything that we are doing. Just let's make sure they're aligned. John, I think that's the only.
Yeah, I'll take those three actions. One is to clarify further on the attachment circuit.
Yeah.
Talk to T's, or rather even post in there and get feedback from them. And then resolve this mobility.
Some
related.
text to say how it's, I think,
And in the worst case, we can change the title.
it's not about title, but let's,
Yeah, it's the
as long as we have
content.
clear clarity on how they're, it's not overlapping with other work that Sadasan pointed out. Yeah.
Right, okay. I'll take those three. Thank you.
Thank you. Next, we have. Which is the next topic? Next.
Okay.
Okay. Next, update on cats.
So good morning, everyone. My name is Minh Ngọc, and today I present our document, Computing Aware Traffic Steering, Consideration for Mobile User Plane Architecture. The next slide. So our document basement is about mobile user plane architecture for DMM draft, another draft inside the working group. And this document proposes a map controller to convert mobility session information into data plane routing information. So our target for this document is that we want to propose that this map architecture can be leveraged to address the optimal routing problem in multi-service instant network scenario. So inside the previous meeting, we said that the goal of the draft is any service scenario. But after we revise the goal, it should be the multiple service instant network scenario. So the brief introduction about this network scenario is that there are multiple service instances of the same service running in different locations. And to select the optimal route, it is important to consider the network and service metric related to each instance. It also the problem discussed in the CAT working group, and this map architecture can be leveraged to address that. Can you go to the next slide?
Doesn't work.
So to
Sorry, one second. Let's make sure.
that's previous one.
Okay.
Yeah,
This is the previous
correct.
one. This is correct.
To select the optimal path, the map architecture component needs to be enhanced. So that we suggest there are three things that it needs to be enhanced. First, it needs to identify the service and its candidate location. And we can refer from the CAT working group. We can use the CAT service ID to identify, to differentiate different services. And we can use the CAT instance selector ID to differentiate different instance of the same service. The second thing is advertise the service deployment information. Then one of the possible solutions is proposed in the interdomain routing working group. They introduce an BGP and NRI that store the CSID and the CSID information of the edge services and attach it to a web router, so that the web router can advertise the service deployment information to other components inside the multi architecture if this solution is used. The third one is advertise service metric information. Another draft inside the interdomain working group proposed a solution that a metadata BGP path architecture, a path attribute, which consists of several sub TLBs that contains different cache metric of the edge service and attached to the web router. By this way, the matrix can be advertised to the map architecture. You go to the next slide. This is how we think the map architecture can be enhanced to support cache capability. So basically, we keep the two original routes that have been proposed inside the map architecture. That is a direct segment route and the session transform route. And the new route needs to be added. It is a metric update route. So for the direct segment route, it's basically the same, no change. It advertises the direct segment extend community ID of the direct segment and the corresponding SRv6 SID of the PE. Then to advertise the metric, then the metric update route need to be used. And this route is also advertised from the PE that attached to the direct segment. But this route not going to the other side PE, it's go to the controller. And the information need to be included inside it. Route is a direct segment extend community ID that the service instance is located on. Then its CSID is CISID and the matrix. And so candidate solution inside the interdomain routing working group can be used for that. And the third is a session transform route. A little bit of a modification here is that because the controller decides optimal instance, then the session transform route need to attack the optimal direct segment extend community ID to the transform route to advertise to the PE on the Xenobi side. And one more information need to be added inside the transform route is the CSID, so that when the PE at the Xenobi side, it receives the packet, it receives the session transform route, then it can transform the packet. It can change the destination to the CSID, and after that, it encapsulated with the segment list that go to the corresponding PE of the optimal direct segment. Next slide, please.
John?
Yeah.
Yeah.
So.
Wait, one second. If you, yeah, go ahead.
Can I ask a quick clarifying question? In the previous slide,
Okay.
there is this, I mean, at the middle, you can see the session information plus CSID. What is the session information? I'd just like to understand what that is.
The session information may include the tunnel endpoint ID of the session, and yeah, I think inside the original route already mentioned something about that, but it should be included. The TID is one of the most important, I believe. Then apart from that, to support the cache, we need to add the service ID, cache service ID.
So CSID is what you guys have defined, or is it in the other specs?
Sorry.
CSID is what this spec is defined?
CSID is a unique ID certified inside the CAT working group.
Is that ID encoded in string or binary or something?
For current right now, the CAT working group, they are still finalized and they are still working on what will be the optimal representation for the CAT service ID. It can be the IP, but it can also be another way. In the interdomain routing group or the routing area working group, they also have another draft that working on this one. In summary, that it is still on the ongoing work and there have been no clear.
I think the John's question is where you find the CSID in the session information in the mobile core. So which session information you mean?
Yeah, that's.
Okay. So I think if we deploy multiple service instance and you want service ID to represent it, then we need to have some kind of similar thing to DNS. We can translate the service ID to multiple contact instance ID, CIS ID. So it must be public to the network operator so that they can, when the request is sent to the SMF, then the
Okay.
information already.
You assume that there's some place to put the CSID in the mobile core signaling. So you assume,
Yeah,
not to
there are
specify
some-
the specific
I
session
agree.
information or information element. So it's still open, right?
Yes.
It's not specified.
It's not special.
So let me see if I understand it right. I mean, it is the session ID is roughly the equivalent of a TE ID. But in this case, there is no TE ID, right? Or is there? There's no tunnel, is there? I mean, not the GTP tunnel.
I don't think he says the TID is a session ID.
Yeah. He's not saying that, John.
It's not,
No,
okay,
he's not
all
saying
right. But there is some other session ID that is going to be, okay. Got it.
Any session information be available for his ID.
We go to the next
Okay.
slide.
Next slide.
So in summary, the map architecture mentioned inside the original draft can address the non-optimal routing problem in multiple service instant network scenario by integrating the CAD capabilities. So the purpose of our draft here is not a separate document. We just want to propose potential enhancement to the original draft. So for example, the possible addition could be a separate map deployment illustration example inside the original draft, or we can mention the MUP CAS integration as a method to partly address the non-optimal routing problem of the multicast consideration inside the 7333 DMM deployment. Thank you. That's all the presentation.
Thank you. Any questions, comments?
Kenji, CMCC. Can you go to the next slide? I try to the next one, about the TID part, because the John asked, yeah, here. I try to understand how are you going to get the TID from the PE side? Yeah, the last box. Yeah.
TEID?
Yeah, the TID. That is the mobile domain information. So, and then your PE, I don't know how your PE going to get that one. That is like the TID for a GTP tunnel. And then it's being assigned from the UPF, or if you use 5G. And the UPF give the SMF, AMF, and then go to GNOB. I don't know how your P is going to use it.
Actually, we just keep the TID information from the original wrap. So inside of the wrap, it said that it can take the TID from session information, and we just keep the same here. And we think that when after the request is sent to the core network, then the control plane need to create a session for that. So
do you mean your CAS controller is going to poke
yes.
the 5G core system to get the TID?
It's actually not a CAS controller, it's a MUFC gonna get it.
Yeah, basically it's out of the scope of 5GS domain, is that right? 5G core domain, is that right?
Yes.
How can you do the authentication, all kind of things? The things like how can you poke or dive into or peek into the 5G core to get those information? I confused.
Okay,
yeah. So sorry about that.
Let's explain. Let's try to explain the idea. So his idea is based on the map architecture. Map architecture doesn't touch any 5G architecture, but just open the API to receive the session information from the mobile core, which may include the TID in the 5G case. In that case, session transform type 2 session transform route advertise TID for the uplink route. That's what he seeded at the basement of the cat map idea.
Okay, so for the TID, are you going to get both the uplink and the downlink?
I think that's uplink
The,
because
the
just,
TID both way,
I think the
because they are different. For the
the
uplink,
instance
yeah.
selection really depends on only on uplink.
Yeah, downlink
No, the
is
TID,
Yeah.
when the GTP tunnel is set up, UPF going to give a TID and the Genobe going to give another TID. Yeah.
I think don't equate this to TAID. I think, yeah, this is a service ID, right? I think,
Okay, sure.
yeah.
Yeah, that will make
Yeah,
me
yeah.
feel good. Thank you.
I think overall, based on John's questions and this discussion, right, I think you guys need to provide a bit more clarity on what is that CSID, how it's used, the relation to TAID and other things.
Yes.
Okay.
Jadong from Huawei. I just saw you mention the drafts in CATS and IDR working group, right? In the previous slides, you have
Previous slide.
mentioned the several drafts in CATS working group and the IDR working group on the metric, service metric. Yeah, right. I just want to say that the service metric draft in IDR is an individual document for now, and it will depend on the framework in the CATS working group. And based on the CATS feedback, we can, the service metric draft can maybe move forward in the IDR working group. So this is maybe just for a reference. Maybe it's not IETF endorsed technology, right? Thank you.
Yes.
Satoru Matsushima as a working group member. So please move forward to the next slide.
Yeah. One second. Yeah.
Okay. The idea using direct segment route, DSD for short, and direct segment route carry the community for map segment and the seed for egress P router. So, and then the step 2 highlighted with the light green color. So CAT metric update route advertise service deployment information beside of the direct segment route. So do you see what if the direct segment route can bring both of the maps segment information with CAT specific information in some attribute, like a metadata idea for in the IDR working group?
I think we should separate the route because the direct segment route only advertise a direct segment. So for the CAF metric update route, we advertise information related to the service. So inside one direct segment, they can have multiple services. So the direct segment route only advertise the reachability information of that direct segment. But the service, each service inside direct segment route is different. So it needs to have a different route.
Okay, you see the service is different from the segment in the map architecture. So you have considered independently for both direct segment and service and the instance. So what if you see the both be integrated, be abstracted in one single segment in map architecture? What do you think?
Can you explain the question again?
Okay, so you define the service and you define the service instance independent from the map direct segment. So that's why. So that's the reason why you need a CAT metric update route.
Yes.
Beside the direct segment route advertisement. So my question is there any possibility to merge both route advertisement into one single advertisement? For example, DSD, direct segment discovery route.
Yeah, I think it's possible to merge, but in this case, then the direct segment route is the scope of direct segment route is not only for direct segment only. It's for specific service. Because as what I understand from your original draft is that the direct segment is to emphasize the segment. It's not targeted service.
Mm-hmm.
So that's why we think.
Yeah, my point is what if we can abstract the service as a segment in the map architecture? That's my
I think it's also
idea.
possible because it is just our idea.
Okay.
For now.
Okay, great, thank you.
Okay, any other questions, comments? Okay. Thank you so much. I think, yeah, let's continue the discussions in the mailing list. Which one is the next one? Suppose traffic steering or
Just follow the order, I think.
what is our? Oh, okay. Mark.
You progress on the slide?
Yeah.
Okay. Good. So my name is Marco Lieb from NEC Labs. We had a good amount of discussion on mobile traffic steering during the last IETF meetings and in between. So people had good ideas on advanced use cases based on today's mobile communication system and its evolution. And there seems to be growing interest, and people always ask for documentation of these things. And here it is. First time we have a draft on it, which hopefully serves as a good starting point for more. Next one. All right, past activity and background on that. So traffic steering is addressing the point of end-to-end in mobile communication system, and mobile communication systems are typically constrained and not really end-to-end. So there is a missing path between a user plane anchor and the data network, which we discussed in the draft. And solutions to tackle that have actually been addressed in DMM and other groups a long time ago already. But now this kind of use cases behind these solutions get a little bit more traction, and people have good ideas, and that justifies more documentation and maybe even doing some standardization work where required. We had discussion between various IETF meetings, and at IETF 117 we could have a public site meeting where even people outside of the DMM working group came and provided good comments, fair comments, also about limitations of what we had in mind. So all of that goes into the draft. Of course, it's not yet too mature, but a good amount of information is in that draft, and there seems to be growing interest. So let's see if we can do something more in DMM. Next one, please. Just to summarize, the basic scenario comes up. If you see a mobile communication system on the left, and we abstract from well-known cellular systems like 3GPP, so, but it's fully in line with it, right? So we don't want to interfere, but complement these systems to have advanced use case in today and in the future. So you see a mobile control plane, you have a radio access network, and one or multiple user plane anchors. So all that can be matched to 3GPP architecture, but it's not dependent on it. So we look actually at the right-hand side. And one example is that a mobile device's user plane anchor gets relocated mid-session. So you may want to steer the traffic. Advanced scenarios even consider a mobile device which has multiple parallel user plane anchors, maybe serving the same mobile user IP, and you need to steer traffic based on policies. Right? So all that are advanced scenarios which we discussed. Traffic steering of non-routable IP. So you need to do something in the transport network to bring these packets from its source to its destination, which is the mobile, and all of them need to traverse the user plane anchor. So these are basically the scenarios we look at. A set of use cases that we described so far, we show later on. Also, network function ephemerality and mobility. It's use cases which people discussed today. So you may have on-path components which are not always present or static. So they may move, they may disappear for energy reasons. So all of that is a good reason to steer traffic in a different way and hopefully in a controlled way.
So if I may ask a quick clarifying question on traffic steering of non-routable IP, what use case
so
in mind?
if you, for example, have a mobile user which gets an IP address assigned, which is topologically anchored at a user plane anchor, and you change that anchor point, so that new anchor may not be in the network matching that IP address. So you need to steer it. So you need a host route for that or other mechanisms.
Yeah. For non-routable IP, I was asking about the non-routable IP. What is non-routable?
So you cannot route it in the correct way by default routes. So you need host routes.
Oh, I see. Okay.
Or
I thought
encapsulation.
non-IP devices. Sorry, my misunderstanding. Okay.
Maybe the wrong term.
Okay. That's fine.
Next slide, please. All right. So past discussion. So we asked, is there interest in this work? If there is value and relevance of this work and the documentation. So all of that seems to be the case. Also, we discussed, as you see in the picture here, a couple of interfaces and reference points where work and standardization could be done. And in particular, the interface between mobile control plane and another control plane, transport control plane, could be standardized in terms of information models. Then forwarding plane, of course, there's a lot going on. The mobile architecture, different alternative mobile user plane and data plane protocols are realistic. So there's a lot of existing work, but in the view of these use cases, there may be additional features to be added to these data planes and forwarding planes. For example, to tackle reordering problems. And in DMM, there is a draft on that, which addresses an important point for these use cases. And so forwarding plane aspects is something the draft could also take a look at and see if there's
just one
something
clarification.
more.
What's the difference between the data plane and the forwarding plane? What's the difference between the data plane and the forwarding plane?
Forwarding plane.
Forwarding plane. Well, it's a protocol applying to the data plane. Right?
Oh, I see.
Yeah.
It's a brand new idea. What's the exact difference? I didn't care about that.
With the data plane, we treat the term as traffic of a mobile user in the routable part, and the forwarding plane. Well, here in this context, we see the protocol applying to the transport network. Of course, any comments on better terms that we appreciate? Next slide, please. Okay. Right, the general topics that came up were beyond user equipment mobility, so including non-terrestrial networks, ephemeral nodes on the path, then moving network functions. So there are good use cases that have been discussed. Mid-session node handover may lead to data plane packet reordering, so problems like that need to be tackled. UE to UE communication is one of the use cases that we address in the draft. Cross-domain mobility aspects, end-to-end QS, so aligning quality of service that you have in a mobile communication system with the rest of the segment from the user plane anchor to the service. Of course, we don't want to reinvent the wheel. If we see the need for standardization, we need to check if there are other groups working on something that can be reused. Yes, there is a comment now or there?
Yeah, just so in general, I think 3GPP doesn't recognize anything on N6, right? They don't, like data, there's only data network, right?
Much.
So now your interface point through is the transport control, right? It's more an API-based interface, right? So technically, if you want to steer something on the N6, right? The transport controller to touching the N6 node is the only interface, correct?
Yes. We have the two architectural options,
Yeah.
which shows this N6 interface in the controller and where we see work to be done on the
Okay.
next slide.
Okay.
Exactly. So that's one of the two options that we describe. One is based on a dedicated transport controller, and here semantics that apply in between that controller and the mobility control plane in various aspects bidirectionally. That's something we want to look at. Then reordering solutions, as addressed before, is something we could look at and discuss for the different forwarding planes. And next slide, please. There is a second option of an architecture without a dedicated centralized controller, but more working with a distributed routing plane. And here we may retrieve semantics from the mobile communication system, not from the control plane, but from the user plane anchors. That's another option where a DPN as a router can be tightly coupled with a user plane anchor, and interactions between these two functional elements is something that also could be looked at in terms of an information model and in the view of the target use cases. Next slide. Okay, lessons learned first draft. So we have a couple of things learned during this discussion and the feedback that we received. Current work, we focus on architecture options, semantics in between the different nodes that are relevant in these in this architecture, and data plane optimization considerations. Starting point in the draft currently is to have a reference architecture, because we don't want to interfere but be compatible with any mobile communication system. So we need a reference architecture with generic terms, but this does not interfere, but really is compatible with well-known mobile communication systems. Documentation on advanced use cases, and this is not saturated, so there is space for 1 to more use cases that we discuss these days. Documentation of end-to-end architecture and deployment options. It's in, but more text and figures could be provided. And then discussion of protocol options and semantics, maybe even better terminology, according to the comments received. And then also information models. That's something we have in mind to do. Next slide. So that's the current structure. As you can see, system evolution and use cases in section 4. We have a bit bigger section on general directions and impact. So how do people see the current mobile communication system evolution? Which use cases should be enabled? So it's more a general discussion. And then we currently have 4 plus 2 others, which have not been covered by the draft yet in terms of use cases. Yes, there is someone in the queue.
You want to take that question?
You could finish.
Okay.
Okay. Yeah, so that's a prerequisite to know what these end-to-end systems should do and tackle in the very end. Then we discussed the framework and the deployment options with the 2 major architecture options that we just visualized. And then concluding that with design recommendation and information models. This section is still to be done, but if there is interest, I think there is a lot of meat in the back of our heads, which can be written down in an updated version. Next slide. Very important. Again, we had actually the plan to publish this earlier. That was really tight with the deadline. So we currently have all the contributing people mentioned in the acknowledgements, which hopefully will be on board of this document as co-authors or further contributors. Next one. So next is to be a bit more agile here and publish version 1 in September with more details and analysis, and also a specification part, at least specification plans, and then to make use of the DMM platform mailing list to discuss. Maybe have one or the other call, and then really have a more mature version at IETF 121 in Dublin. And if there is group interest, I think there is also energy from different people to progress such work. Thank you.
Okay, Luigi, I have two questions. Let's say first is
Please state your name, please.
Luigi. I stated. What will the mobility control plane look like? What will be beyond the box?
I mean, generally, you have a control plane in the mobile communication system that treats handover, reachability, security, these kind of aspects. Advanced architectures have dedicated gateways to allow third parties to read or write information to the control plane. If we refer to 5G and 3GPP, there is, of course, the AMF, the SMF. That's the control plane of the mobile communication system. If you refer to that kind of gateway, there is the NF functions, which can be used by outside components. Does that clarify the question?
Okay, can you go back to slide 3, I think, or 4, when there is the general scenario at the beginning? This perfect. Now, if you change the acronym UPA to XTR, if you change mobility control plane to Lisp mapping system, then you have Lisp. Now, Lisp is standard track, maybe does not answer all the requirements that you have. For example, it doesn't look at all to packet reordering. It's completely out of the scope, never consider it. But if you go forward with this kind of work, you definitely need to compare to Lisp and say why Lisp is not enough, because otherwise the problem has been solved already. Then you may choose to enhance Lisp or not, it's up to you. But yeah, have a look.
Yeah, Lisp, we spent a couple of thoughts, and I also had a discussion with Dino on this kind of deployment. And well, yeah, you may apply Lisp on this N6 reference point here, but it has constraints, right? And so you may treat the DPA, the current DPA, as a locator, but what if you have multiple locators, if you have multiple UPAs operated in parallel and you want to have some traffic here, some traffic here. And some traffic here may be the case that you have a UPA which is associated with a non-terrestrial network node, right, which may disappear. So you need to be agile.
You can do that in principle with Lisp, but that's beyond the point. My real point is have a look, because even if you go, if this work goes on, I mean, at some point there will be internet and ISG review, and the same question will come up. Why not Lisp? So
well, Lisp is based also on
be ready and answer already the question in your draft, so you are done.
Oh, definitely, we'll look at it. But also I see constraint in the mapping base, right? Which is that transport nodes pull the state of the EID to locator mapping, right? So there is no way yet, maybe it will be in the future, to push an updated state to these data plane nodes, right?
Go ahead.
Actually, it's not true, because we have a publish subscribe solution. So you subscribe and whatever update you want, you will receive it. I mean,
so transport nodes are subscribers to receive updated information.
I mean, maybe revise a little bit the documents. I can help if you wish, but that. Yeah.
Again, we don't want to be specific on a particular solution for that transport, and Lisp is definitely something we could look at.
Sure, Gandavalli. So if I may comment on that, right, is the key discussion steering to a particular RLOC? That's the only difference. Isn't it? Steering the packet to a particular RLOC, right? That's all. That's the only difference, right? It's a semantics. My point is on N6, when you do steering, right, we steer it to the new UPF. In this case, we steer it to a given RLOC, routing locator. That's the only difference.
Yeah. But really, this scenario is completely overlapping Lisp, completely, except for the arguments. Then maybe there are other requirements that obviously are not in this slide that are needed. I don't know. We can discuss further, but this is covered.
This is a base scenario, so the more advanced use cases we can look at if Lisp is a suitable solution too.
But how the mapping lookup is done is different, right? In this case, the mobile control plane is pushing that N6 steering state. But in case of Lisp, somebody has to insert that mapping state, and now on a user plane when a packet arrives, you're looking up the map lookup.
No. So the mapping itself, you can register. Once you create a map, you register. Then the other side, if it is interested, he express the interest and he receives updates whenever they are available. So,
Pops up.
so I mean, again, I'm not saying you have to use Lispos or absolutely not, but there is a lot of overlap, and you better clarify before reaching the ISO. That's all.
Fair point. Yeah, thank you.
That's what we say here. We don't want to reinvent the wheel, right? If there is IETF work that can be reused, we will reuse it. Okay. So I think last time there was this point from about the charter, right? So we had a brief look, and if the group has interest in working on that, we don't think a rechartering is necessarily required, but maybe a milestone needs to be added. So there are a couple of statements which fit to that work. So forwarding path and signaling, these kind of paragraphs, I think they can be matched to this, but maybe there are other views. I think it's a major thing to recharter, right? But if we can add a milestone.
I think my view, then I'll let Satoru-san speak about this. Overall, I think two things we need to make sure. Are we stepping on 3GPP? In the given that it's N6 node, I'm slightly bit comfortable, right? Personally, I have to discuss with Satoru-san, but overall, yeah, looks okay. But I think in general, we need to, from any new work, we want to issue an LS to 3GPP and make sure they're okay with that. That's one thing, right? And then we have to make sure it's in charter. Then the third most important thing is there's sufficient interest in the work. If these steps are met, I think it looks okay.
I think it would be good to study whether the architecture or some sort of the framework be standardized. But finally, at the end, we have to adopt the exact solution to make things happen. So let's study whether we can reach that level of the work. That's my opinion.
Well, I think a fundamental decision we need to do, not later, but now, is how much 3GPP specific want to be in that draft, right? I mean, if you want to issue a liaison
in terms of the
statement-
3GPP specific thing, so currently 3GPP doesn't have the much scenario for a UPF re-anchoring. So if you assume 5G, we have no space to work on that.
Yes, that's why we abstracted actually from that. It's compatible with 3GPP architecture, but not dependent on it.
So, okay, so if you assume 3GPP, how you assume UPF re-anchoring?
I don't assume 3GPP. I assume a mobile communication control plane. and
Okay,
data
so
plane
what's
anchors.
mobile communication system assume? So in the real world,
Well, something
we are
that
running,
derives
working
from-
on IETF, running code and rough consensus. So
Yes.
what you assume as a running system?
Well, we may develop a running system based on PMAP. I don't know. Well, the point is we try to close the gap, which we found in current 3GPP system.
Okay, okay, my comment is if you assume it's 5G doesn't see much scenario for a UPF re-anchoring. So in that scenario, how you assume UPF re-anchoring be happen in the real world? That's my question. It's not.
But 3GPP
It's not
specs
clear
are
for me.
not frozen, right? There is an evolution, even
Of course.
next generation being discussed.
Okay,
so
so
people
you-
have different ideas on which use cases make sense, and hopefully the future mobile communication system will bring support for that.
Okay, so you assume that future mobile communication system which adopt UPF re-anchoring.
For example, or multiple UPF support. I mean, session and service continuity modes in current 3GPP, they support something like UPF relocation.
Okay, you assume a future system. Okay,
Current system and future system.
current system doesn't have that.
Well, for current system, we may add also use case, maybe we have already, where this end-to-end system makes already sense now. in the view of QS, for example, in the view of UE to UE communication.
As far as I know, the CGPP does define the UPF reanchoring, but it doesn't provide IP address continuity.
This is true. Yes.
On N9, there is continuity, isn't it? On N9 interface.
N9 is inside the core.
Inside the core. Okay. That's only. No, but even the Marcos scenario is reanchoring is within the core. The steering is outside from N6.
This is only one use case, right? Look at the other use cases where
Okay.
we don't have UPF relocation.
Okay, so without reanchoring, why you need steering to change the anchor from the outside of the core?
Well, as said before, there may be use cases where UE has multiple user plane anchors, and one may be a lightweight one, another one a heavyweight, and then you may receive traffic from different sources. So you may want to decide policy-based which UPA use for which traffic.
Okay.
Which means you need to steer it. There was another comment.
Was there a comment?
Raj Schmidt from Huawei, Canada. Just a quick one, Marco. I guess the point that Satoru-san and Siri are trying to actually bring up is that you need to be aware of whether you're generating a new requirement for 3GPP. Like if there is something in 5G that actually need to be done, then someone has to bring it on the other side to invoke this work on both sides. Otherwise, if they are not taking any actions, then you're basically assuming that there will be some action. Some way we have to make them aware of that. Okay, so if you want to know this, then this type of thing has to be added into the requirements for 5G plus at least.
Yeah, I mean, there are different strategies to bring this ahead, right? I mean, either you go to 3GPP and argue for new use cases, then you start in SA1 with new use cases, then you bring it to SA2. And then still we have the gap of the non-3GPP part, right? Or we start with something in the IETF on the non-3GPP part and make a good proposal on how to interwork and operate these use cases, and then 3GPP may decide to support these informational data models that we are about to specify. Right? And the framework is there from the 3GPP side. So there is the NEF and the AF kind of things which you can move out of the 3GPP space, which just need the semantics to control that. So, Sanji.
I can volunteer some information to substantiate the argument about the anchoring, re-anchoring, or to have the transport plane to control the like a UPA here or UPF anchor, re-anchor inside the 5G. Because there's some project going on right now. Is like edge computing part, and there are quite a few issues. One key issue is like to have the N6 decide to use the delay from the anchor, well, called UPF, but here probably called UPA, and to test or to measure from the UPF toward the Edge AS application server, and then use that information to feedback through the AF, as Marco mentioned, and then to influence how the UPF is going to select different EAS, those type of things. So this is being done. It's going to be done by the end of the year in 3GPP. Yeah, I'm happy with that project there. Yeah, so I think this is a good work, and then it does have some room to proceed. So thank you.
Thank you.
Thank you, Chandra.
Any other questions, comments?
Just one clarification. So during discussion, I think your point is you assume the multiple anchor rather than re-anchoring. Is that correct?
Both.
Both, okay.
If there are use cases in the draft which don't make sense, of course, it's version 0.0. We can revise according to the needs and the view of the working group. It's just a starting point.
And also the defined adopted solution is out of scope of this work, right?
Which solution?
So adopting exact solution is out of scope.
Well, we have currently a section on design recommendations and information models. So information models may apply between the mobile communication system control plane and the transport network control plane, according to the use cases to support them. So that's something we consider. So it may be, that may be the specification part in the document.
Okay, so you define the information model, data model,
Yes.
that without the exact protocol.
That's why we said information model. If there is
Okay.
something more concrete, it can be extended towards the API that applies to 3GPP, for
Okay.
example. So I think information model is a good starting point.
Okay.
So the Lisp discussion we just had falls into the information model discussion or more specific solution?
Lisp?
Yeah, the Lisp discussion.
Well, I think first we need to see what Lisp brings today and if there are gaps in Lisp to support the use cases we have in mind. And then, of course, Lisp is a standalone system. So how to interconnect to a mobile communication system to drive these use cases, that's also to be looked at.
Which again, I think is more on the solution side. I mean, you have your model, and then you may think, because it's similar, whether or not Lisp satisfies your model and can be a concrete solution. That's my personal opinion.
Thank you. Okay, thank you, Marco.
Okay,
Any
thank
other
you.
questions? Yeah. Okay, Jeffrey.
Yeah. Good morning, Tianji here. This is, I don't know how many times we have done this presentation. Oh, by the way, Tianji from CMCC. This is the nice version of this. Oh,
Yeah, one second.
yeah, the fonts are kind of, yeah, okay. So try to give some, bunch of authors from different companies like mobile operator, service provider, solution provider, equipment vendors. This is like a collaborate thoughts, opinions, and contributions. So this, I don't know, maybe the fifth or seventh presentation on the work. Okay, next one. And then, this is just the agenda for the first three bullets. It recaptures.
So Jeffrey, I think the key thing is there was an adoption call, just to level set the discussion, right? There was an adoption call. There was some good amount of feedback, right?
Yeah.
I think the key thing from our point of view is we have to make a decision whether there's a path for this or not, right? So you have one in this presentation we can address, right? What were the key comments? How you have resolved it, right? And then we take it to the working group. If the guys who have provided that input still disagree with that, there's no path.
Yes,
So
exactly.
this is the last time.
So
Yeah.
that means like I don't need to go to the recapture.
Yeah.
Yeah. Okay. Yeah. Just go quickly and then go to the next one. Just can you go to the next slide? It just Yeah. Here are three bullets about the recaptures from different IETFs. And the last bullet is actually something we have done since IETF 119 in Brisbane in March. And then from there, when we answered the comments from the first adoption call in last November, we provide answers, feedback. And then after that, in March, IETF 119.
Can you a little bit? You're too close to the mic.
Oh, maybe it's better? No?
A little bit.
How about right now?
Yeah.
Good? Okay, sorry about that. Yeah, so it's just this time I try to address the feedback and the comments from the comment feedback answers we gave for the adoption call. Okay, yeah, next. Well, probably this one has been presented already. I just try to emphasize we have done a lot of works and also what have been the first time for the adoption discussions, what have been achieved, and also about okay why we want to get the work, especially for the the incoming the 6G roadmap, of course, those type of things. I'm going to touch fundamentally or basically in later slides. So next one here, this is the first comments, and then from the adoption call in last November, and then we answers on the mailing alias, and also give our argument and the revisions in the new draft to see all the all kind of things. I don't want to give, don't need to go all the details since I have already done the presentation last time. Yeah, next. Yeah, this is the second one about the number 2 major comment. Basically, there are 3 major comments. So there are issues with our answers and the chair's review. And go next one. And our arguments and the changes, all kind of things. Yeah, this is the second. Can go to next comments. Yeah, regarding this one, basically all the same thing, like issues, our answer, chair's review, and then our arguments and the changes. Yeah, go to next. Yeah, this just skip it. Just this is just argument. Yeah, this is the last time what we have done based on the feedback comments from the group. Yeah, this is until the number 08. So the work by this slide were finished or done in IETF 119. That was like 4 months back. And since then, can you go to the next one? In 119, when I did the presentation, I got one major comment about this. Okay, how are you going to use the draft? What a reader can do with it. So in this new draft, I try to answer this question. Okay, what a user or reader can do with it. So add individual section as highlighted in cyan, I think the color of blue. So to say, okay, the ANOOP implications from IETF to 3GPP. So give the comparer, give explanation, UP, CP, and the impact intention. So basically the intention of the draft to 5G and the later 6G evolution. Because using 6G evolution more, in the 3GPP world, we call it, it's not a revolution this time. 6G will be evolution this time. So yeah, so this is all the answers about it. And also, okay, what will be the advisory references from IETF to 3GPP? And okay, it's embedded all over the places in the ID. So yeah, that is the major update. Here, I just try to give a comparison what is being done in the IETF TEAS TIS group. So in the plenary of the 3GPP SA meeting last month, there was one document. Well, it's a famous document, always. IETF status update to TSG. Always there. Every plenary, every 3GP plenary will have this one presented by the IETF liaison manager to 3GPP. So there's the one document from the TEA about realization of network slice for 5G network using current IP MPLS. So basically, this one has been sent from IETF to 3GPP. This is a working group adopt the document, by the way, by TES. If they ask, okay, this is basically, if you look at the bottom picture, this is just I capture as a slide from that IETF to 3GPP document. Basically, it said, okay, 3GPP, this is the work being done by TES working group. And then can you provide something? We have done some work. So 3GPP regarding 5G, we have done this work. This is our contribution. Can you provide some feedback, your comments, your concerns, clarification? This is like advisory reference. By the way, this working group adopt document is the informational document. So that means the work in IETF and to reference being later. I think the purpose is later for 3GPP. So that is the thing. Actually, I also got inspired basically about the similar things because I involved in 3GPP a lot. So I knew this one. So that's why this time I listed this one here to show, okay, there was some room like a 3G IETF done some work, and then later that can be like a informational reference guide to the 3GPP. So that's why I put the similar paths could be applied to the map here. Yeah, can you go to the next one? Yeah, this is just like the difference, the comparison between 0.8 and the 0.9. And then I have already gone through the difference. So the conclusion part here about the major thing I want to emphasize here is like the 6G will starting next year. There will be a workshop next March in Europe. I forget where, maybe in Spain or whatever. And then in the 6G, there were already a lot of documents discussed what the architecture, what will be network like. I think maybe more than, I forget, well, maybe 40 documents have been proposed at the end of May in Jeju Island, South Korea, talking about, okay, the requirement, all kind of things for 6G. And then, and also, you know, there are a lot of discussion about the distributed and autonomous networks for 6G. This time is not just for the core network like a 5GS, but here quite a few contributions are talking about the distributed and autonomous for the access part, like you know, talking about like the radio unit part, the DU part, the CU. So basically like to try to distribute and disaggregate the networks across both AN access and the core. And the 6G workshop is also imminent. So all kind of work just inspired us. Okay, can we, you know, this, you know, we still want to emphasize this work is still IETF work. We try to find something and then to summarize something can be from the IETF side, because if we get the distributed networks later, well, you have lots of disaggregated components, network functions, and then they need to be connected. And then maybe in some situation, some component or network functions be integrated at one moment in the 6G evolution. That's why here, okay, you know, we believe this is the right time because the 6G workshop of 6G is there just around the corner. That's why we want to, okay, can we, after we address all the common feedback from previous things from the groups. So that's why we bring this one here again. Yes. Yeah, that is. Thank you.
Thank you. Any questions, comments?
Luigi, can you go back just one slide? I mean, just yeah, on the section 5 that has been added, I was skimming through it. I think it could go a little bit further in the sense that, as you said, the 3GPP will have 40 documents to analyze. Okay, the clearer are the documents, specifically this one, the better are the chances that there is something to really be discussed with 3GPP. So maybe Section 5 should really include some list of requirements or evolution path of the control plane. I mean, as of now, it doesn't say much. It's just it's up to the 3GPP to do it, but doesn't give any real hint on what should be done. And maybe adding that hint will be a win for this document. My opinion.
Yeah. Can I answer? Yeah, Liz here, this is a good suggestion, but since during our previous discussion and also adoption call, there are like a comment say, okay, are you going to step into the control plane of 3GPP? So that's why we try to avoid,
I understand, and this is a fine line to walk over, but it's not to do the job of 3GPP, is just to give some hint of where it's meaningful to go. So to ease the job of the 3GPP, and they better understand the whole solution, and they may say, wow, this is cool and we should do it.
Okay, yes, yeah, I will memorize it.
Satoru, as a working group member, please go to slide 7 or 8. 7. Sorry, 8. Yes, I think we have miscommunication here. The reply to the adoption call from chair side mention about the running code but not to mention about the 3GPP process. We working on IETF, so if also mention rough consensus, it would be reasonable to ask where is the running code. Otherwise, so there's no contribution, no tangible contribution to other SEO. That's why we mention running code to reply the rough consensus be asked.
Here's the no running code because the mention about this the real work is targeting for the 6G things, and then I try to use the event to explain our work is on which stage of that things. So that's why we try to answer no code, no need to have the running code, and then actually we don't have it because this is for future. Yeah.
Yeah, I think I understand the 3GPP process, which doesn't require running code, but from the contribution aspect, from IETF's point of view, if author mention about rough consensus, it's reasonable to ask where is the running code. We are working on IETF, we are not working on 3GPP. We can contribute to 3GPP work, but we need tangible things from the IETF work. That's what we replied to the authors for the working group adoption call.
Yeah, can talk to you later because I got a little bit confused on the boundary line here about the do we provide the code or? Okay.
My point is we are not working on 3GPP. We are not follow the 3GPP process. I understand, and all of the working group member understand that the 3GPP process, especially on stage 1 or 2, doesn't require running code. But here in IETF, the author replied to the question to the mail with the rough consensus be formed in the IETF working group. So it's reasonable to ask where is the running code if author asks rough consensus. Without running code, how to make rough consensus is my point.
Okay,
from IETF point of view.
Code. So I look at all the adopted drafts. Do they have a running codes?
No. I don't think so. I don't mention that, especially for this working group adoption call. Also mention rough consensus. Okay, it's good. So if you ask rough consensus, where is the running code? Is a reasonable question. That's my thought.
Okay. I got confused. Really, it's because
I'm sorry.
I'm looking at the difference from other drafts. So
I suggest have an offline discussion.
Yeah. Okay, sure.
Because
No
I think Satoru-san's point is about the rough consensus that you guys have asserted, and then.
Yeah, I understand that part, but look at the other draft. I don't see the similar things. That's why I got confused. Why,
We can have this discussion.
Yeah. Okay, sure.
Yeah. Please. Yeah. Next.
Jeffrey Zhang from Juniper. Thanks for keep working on this, giving us the updates. I especially appreciate the update on the ongoing, upcoming 6G work in 3GPP, the workshop. I think that's a very important information. We started this discussion in IETF because we have a group of people with both IETF and 3GPP background consider this problem. We believe this is a good evolution for the mobile user plan in 6G, and we believe we have gained enough consensus, and it's not unanimous, but we gained enough consensus among the people who are interested in this topic. And I know that there are mobile operators interested in this. In particular, I know that Tianji works for CMCC and closely with their mobile people. This is something that's, I think it is valuable to have a IETF contribution to for the 3GPP to consider. So I do appreciate that we can move this work forward as an input to 3GPP for the upcoming 6U work. Now, a very quick comment on the running code part. I'm a little bit confused there, but if the block here is that we don't have running code for this proposal for the upcoming 6G discussion evolution, then I'm lost. And if that is indeed the problem, I guess we just have to give up on our contribution here.
Thank you, Jeffrey. The next is Yuya.
Oh, can you hear me? Can you hear me?
Yeah.
Okay, so I'd like to confirm again the motivation to adapt this draft to the working group and the motivation you are going to input this draft to the 3GPP as IETF working group draft. So the big difference between this draft and the draft in the TIA's working group about the network slicing is, so we have a IETF defined network slicing and running code and implementation and deployment and already inside the mobile operators. And with my understanding, so the reason about the network slicing, and you mentioned about in the slide, is a very good input to 3GPP. But so this ANIP have no running code and implementation and deployment yet. And that is a very big difference between the draft about the network slicing in TIA's working group. So I'd like to confirm the motivation to input this draft as IETF. So you like to input this draft and this information to the 3GPP as an IETF official document.
Okay, thank you. Yeah.
Answer. Here, I use that network slicing part as an analogy. I don't say, okay, well, we are going to use the same technologies. But remember, network slicing is, I think the release 17 is a long time back. But here, this is for future 6G evolution. So it's not like an apple to peer comparison, but just give analogy for the paths that can be achieved from the IETF to 3GP as advisory reference guide.
Okay,
I know that. So we are now going to input the requirement to the 6G. I think for release 19 or 20, and so why are you going to? Are you not going to input as a 3GPP members to the 3GPP working group? But so now you are going to input this information to 3GPP as IETF.
Okay, thank you. Yeah. Next, John.
John from FutureWay. I wanted to say that this draft does provide useful information about some optimizations. I think the way it's framed, though, is that it's providing suggestions to 3GPP. And I think that's the part where it would be useful to frame it as, there are some advantages to doing X, Y, and Z, and then leave it up to 3GPP to adopt. I mean, putting it as it's too close a connection, and it almost looks like that the IETF is recommending something. So if we leave that connection out, I think there is valuable options and optimizations that are suggested in this. So how you do that is
okay. Thank you, John. Suresh, last comment.
Yeah, thanks, John. So I think I agree with what John said. That is part of also my concern. We provide this kind of say, hey, you should do this, but not really calling out the implementation stuff, right? Just to follow up on Satoru-san's thing, I don't think I think Satoru-san meant it, but just make sure that that's clear that it is not a barrier for adoption. The existence of an implementation is not a barrier for adoption, but personally for me, after reading the draft, it's not clear what needs to get implemented. I think if you can focus a little bit on how somebody could implement some of the things in here, I think it's going to be very useful. for somebody who wants to implement it, right? Because I think that could be a barrier for adoption, because it's not clear like how to go about like with the recommendations, like, and who has to do it. I think that needs to be called out, and that might go into the same point that John brought up, right? Like, who's this for, right? Like, who would take these recommendations and do something with it, and what they should do is probably worth like spending a little bit of time on for the draft. Thanks.
Okay, thank you, Suresh. Thank
Okay,
you.
yeah.
I think key point. I think overall there have been many comments in the adoption call. I think I think this should go back to the mailing list, right?
Okay, sure, no
Please,
problem.
yeah, post this, right? And let's discuss this. in the
Okay,
mailing
sure,
list.
yeah.
If there's consensus, we move forward. Otherwise, we stop it here.
Sure, no
Yeah?
problem. Thank you.
Thank you. Okay, next. Okay, next I'm going to cover this emergency. I'll take a very short time on this. I think. Yeah, this is not in the charter at this time. I think the key discussion point, I want to get some feedback on, what we need to do around this. I think the use case that I'm looking at is like, how we can enable emergency 911 or 112 calling over Wi-Fi networks. That's the scenario that we have. Today, if you look at it, emergency calling is only supported in cellular networks. So I gave an update in the last IETF. There are some new additions, right? Overall, I think the key discussion point is, there's so much of noise. Okay, the key discussion point is, what we can do in IETF, and if there are any elements that will fall in the DMM scope. So I think the scenario description is, I think the assumption is the user is in some environment where there's only, Wi-Fi or public cellular network is not available. Let's say I'm here in the basement. I don't have cellular connectivity. Now I want to make an emergency call. I don't have access network credentials, meaning I do not have the password or for this SSID. That's where I am. I'm in a mall or in some environment, public, in a mall. Can I make that emergency call using a native dialer? That's the scenario we have in mind. Now, so I think from the technical elements, if you look at it, what we want is that, can I take a device, let's say I pull out my Samsung or Android device. If anytime I press a 911 or 112, do I automatically discover a network which supports emergency services? And will I be able to latch on to that network with only one purpose, to make that emergency call? That's all. That's the objective. I'll not be allowed to do anything else but make that one single call. That's the scenario. In this, so the elements from the solution point of view, how do I discover a network and which supports emergency services, right? Maybe perhaps using emergency pass point profiles. The definition of emergency pass point profile is not there yet, but can we define a pass point profile with some special characteristics, which is exclusively, which allows me to discover an emergency network? And this pass point profile should be bundled as part of when device manufacturers like Apple's and Samsung or Microsoft, when they make a device, this profile is already present in that. Now, the other aspects in this is like, how my location is signaled, right? What as an endpoint, what do I signal? Is that location a trustworthy location? Meaning I can make a rogue call sitting here and saying I'm in San Francisco. How can the emergency system be in a position to know that this call is coming from a real location? These are some of the considerations. Then the other issue is when I use a native dialer, not an app. When I make a native dialer, when I press a 911 or 112, what is the backend infra that supports the SIP termination, SIP call? So these are some of the elements, like how do you detect a rogue user? Now, I think overall from the solution elements point of view, this is one type of architecture, right? I think meaning the baseline assumption is there's a pass point profile which is supported across various Wi-Fi roaming architectures, right? Even cellular in one sense, right? So pass point profile is the enabler. It allows me to discover a network. This is common for across, if you take eduroam or open roaming or, you know, 5 other roaming architectures, in all of these, the common element is a pass point profile. So the starting point here is, can we standardize something, right? Can we make recommendations for, you know, enabling, you know, come out with the definition for emergency pass point profile? Now, that will be the basis where it will work across all of these roaming architectures, meaning a user in a given situation will be able to latch onto the network and make that call. Now, the other elements, I think, you know, as part of there have been some discussions in FCC, in FCC's history. FCC is the regulatory entity in the United States. We took technical specifications saying, like, you know, we made specific recommendations to FCC saying that, like, you know, if your goal is to promote roaming emergency calling, you have to designate one of the operator, right? Like AT&T, Verizon's, like, you know, to allow emergency call termination from Wi-Fi devices, right? This rule making is under review. So here, what does it mean? The cloud that I'm showing here is designated by an FCC, right? There's an identity provider there, right? Meaning this identity provider, when I bring in my a device with an emergency pass point profile, when I activate that, right, the signaling happens to that identity provider. The access network will signal the location to that identity provider. Now, when I make an emergency call, the call termination will happen on the ECSCF or the emergency SIP server. So this is the overall, you know, architecture. Now, I think a brief discussion on, I think, you know, the pass point profile. I think, you know, a few things. I think this is why IETF has to look into this, right? Pass point profiles have a certain structure. There's an ordering, right? Now, where does an emergency pass point profile fit into this, right? There's no order, right? It's an invocation of the emergency pass point profile is explicit, meaning I press, based on my intent, right? If I press 911, I activate that profile. If I call my wife, that profile should not be activated, right? That the intent is very, it has to be explicit, meaning I want to make an emergency call, that profile has to be activated. Now, so that means that we have to make a recommendation, right? When we define an emergency pass point profile, where it fits in the list of profiles, what is the ordering, right? How does that get invoked, right? In some countries, the emergency call is not by a native dialer, but you know, based on a specific designated application. Any time I invoke that application, that profile has to be selected. So meaning in the OS, we need some abstraction saying, like, you know, how we invoke what are the events, right, you know, that allow the operating system to select that profile and activate that profile, right? There are a number of gaps here. I think, you know, we want to, you know, publish some material so that all of these are addressed, right? Now, in the context of emergency pass point profile, I take my device. Let's say right now I'm an US citizen. I'm in Canada. What is my profile? When I make I'm roaming in one sense, right? Now, in this sense, what emergency profile should I use? Is it a Canadian emergency profile or a North American, United States profile? So there has to be a local element in the profile, right? I think and there has to be some additional metadata elements which marks the profile as a emergency profile. These are all some of the elements in the puzzle. Now, I think I think this is an example. Like, you know, if you look at it, Apple has, like, you know, some devices, when you press some specific hotkeys, right, a special screen pops up, right? Here, can this be a trigger to select the emergency pass point profile, right? I think these are some of the other discussion points. Now, location considerations, you know, in all emergency systems, location is central to everything, right? I think this is where there's a touch relation to the work in DMM, because in the context of mobility, location is fundamental. You allow, before we provide mobility, we allow the device to latch onto the network. Then, you know, we know the network knows the location. So I think this is one touch point, but coming back to the emergency calling, location is central to. Yeah. Okay. So yeah, emergency the location is central to, is it the location of the end user, or is it the location of the access network? What is the confidence level? Is it 90% possible that the last reported location is 5 minutes back or 1 minute back? What's the confidence level? I think so. In all of this, the central to this, I think this slide is not, yeah, I think the question is, if you look at, when I make a SIP call, there's some SIP headers, I can indicate some location, right? But that location may or may not be accurate because that depends on the device. Now here, this is where the touch point is. Let the device report what it is, right? But on the back end, the access network will also report a location. That way, the emergency system will be able to cross-correlate between the location that's reported by the endpoint and the access network is saying. So this is a way to know whether the location that is getting reported to the network is the right location or not, right? I think another thing is, if access network can provide a signed location to the device, then the tag itself can be used to index the location. Meaning, like, the flow is something like, I make a call, I'm connected, I make a call, I have some specific location tag. That emergency voice system, the SIP server, will be able to do a location dip based on the tag that I provide. And if I'm connected to the right access network, if the access network has reported that location to the database, location database, the subscriber's location can be retrieved, right? But if my tag is not something randomly generated, the location dip will fail, right? So there are ways to solve the location problem and in the right manner. That is one thing. I think this is about the dynamically generated location tags. I think now there are two scenarios, right? I think I am already connected. I think let's also take the case, in this case, let's say I'm already connected to this network. Now, yeah, this is much better now. Now I make this emergency call, right? In this case, because I'm already using some other, let's say Google or a T-Mobile or a AT&T passpoint profile, I'm already connected. Now when I make an emergency call, my location was reported to the identity provider of that first network, meaning AT&T or whatever, right? Now when I make an emergency call, how does the emergency system discover the location, right? In one case, if everything is under one realm, meaning the identity provider and the voice services are in one realm, the location is, fairly straightforward. But if there are two different entities, meaning the passpoint profile that I use, let's say for its IETF passpoint profile, now I make an emergency call. My call terminates in the SIP services in the cloud, that's somewhere else, FCC designated. How does that entity look up the location database, right? This is where I think, we are suggesting some NAPTER, DNS records, right? Based on that, in the SIP headers, there's some realm information. Based on that, you discover the location by make a DNS query, and subsequently do a location dip based on what the station is providing. These are some of the elements, I think, in the overall solution puzzle. I think my mouse is not moving. Yeah, I think just to illustrate, I think, what we are building is probably maybe in next IETF or something, we'll be able to, maybe in the hackathon, we want to demonstrate the whole thing, right? I think, let's say I'm attached to network one, I using an emergency profile, I attach, make an emergency call. The PSAP lookup, PSAP is public safety answering point. That lookup happens based on my location, that's the access network is providing, and the call gets routed to the right location. The same device go to access network 2, I make the same call, this time the call goes to a different PSAP, right? This is what we'll demonstrate, right? Now I think this is where overall, I think I'm trying to see, like, what's the best place. I think, art, Eric says art is a group where we should do this work, but there's no home right now, right? I think that's an open question, but this is where I am happy to take any questions, but right now this is not in the charter, just to be very clear, right? And maybe what we'll do, yeah, John.
Actually, sorry, this is more a question for clarification. I think my understanding of the location makes a lot of sense. How are the identities, or is there a separate identity that exists, or is the IMEI or whatever
Yeah.
identity that exists in the cellular domain, is that somehow authenticated and sent, or?
So there are two scenarios, John. I think, if you look at today's cellular stuff right now, even expat SIM, somebody with an expat SIM can make a call, right? In one sense, there's no subscription
Right.
relation there. All we are providing is an IMEI in one sense, right? Now, coming back to, I think, but based on the FCC discussion, there's an interest to know where the call is coming from, right? I think, but that changes based on the regulatory domain. Maybe if you go to China, the view will be different versus what we say in the United States, right, or Canada, right? So we have to support multiple models. When we make a SIP call, one approach is every device, Apples and Samsungs, they already have a device certificate, right? Can that be signed by the device certificate? That way, the receiving entity knows that this is signed by Apple, right? And this is the serial number, this is a MAC address, right? That's one way of level of authentication, right?
Sorry, just to clarify, you said the signature is for the MAC address, or, but could it be
Some
for
stable identifiers on the device? That's
Okay,
all. Yeah,
I see.
yeah. It could be even IMEI if the device has an cellular modem. If there's IMEI, PEI is there, that can be used as an identifier too. But we also have to consider devices which don't have cellular modem.
So maybe I misspoke. It's not IMEI that I was intending, more like a SUPI or an IMSI. So.
Yeah, for SUPI or SUKI, I think then certificate-based signing. If the device has Apple installs a cert or Samsung installs a cert on the device by default, when they make that SIP, headers have to be signed using that private keys of that. That way, the receiving entity knows that, okay, this is an signed by Apple installed cert, right? That's one way of, right? The other thing is keep it open. Or third option is keep same credentials on every device, right? All are possible, but yeah, those are different ways to authenticate the device.
Any preference for one model or the other, or it depends on the location or the?
Based on the regulatory domain. Yeah.
Thank you.
Thanks. So yeah, this is where we are. I think, yeah, Jeffrey. Yeah.
Yeah, I'm trying to find some working group for this work because for location-based service, I think if you try to talk about mobile service, normally you're going to get a precise location through the control plane here. And then here you involve the IMS, so it's a SIP call. Yeah, is there like a voice working group for this type of things? Because you're using IMS.
We are not touching IMS though.
Yeah, but
IMS is more
you mean you have
over
to
the
use them as
top.
call
Yeah.
now, right? Not like the IP call or something. Yeah,
It's over the top. I think it could be, yeah, we are not touching IMS. It can be any standard 3261 RFC 3261 compliant SIP server. Right?
Okay.
IMS, we kept it, is easier if operators support these emergency services for Wi-Fi. They can reuse their existing infrastructure. That's the thinking.
Yeah, but you talk about the location consideration. Well, here, this type of thing is better for emergency. It's better to get a precise location. Yeah, that information most will be from the mobile control plane.
So
Yeah,
this is Wi-Fi. This is Wi-Fi network though. So this is Wi-Fi network. That's why if you look at the signaling happens from the access point as part of the radius extensions, RFC 5580 attributes location signaling happens. I think that's what we are going to use.
Okay. Well, I don't. I cannot find a good working group yet.
Yeah.
So I try to find one for this,
yeah,
but I can see some discrepancy from DMM. Yeah, at the moment. So
fair point. Fair point. Yeah, fair point. Yeah. Eric.
Yeah, thank you, Sri. Sort of different questions with different hats. First, no hats question. Your overall proposal, I know I've asked this before, and I apologize for not remembering. You are not proposing any protocol extensions or any new things. Everything you are doing here is assembling things that already exist.
Yeah.
Correct?
Yeah.
Okay.
The logics.
So then, one possible strategy is to go to the independent stream editor.
Say that again, Eric. Sorry.
One possible strategy is to go to the independent stream editor.
Interior.
No, independent.
Independent. Okay.
Yeah.
Okay.
Because you're not asking for any protocol changes. You're just mixing a bunch of stuff that already exists.
Right.
So, and then, no hats again, but, well, an author hat, to double check the thing that is, the entity that needs to be located is the source IP address of the SIP call. Is that correct?
Yeah, I'm having a slight hard time, actually. I don't know why. Yeah, sorry, I couldn't.
I'm sorry, the entity to be identified is the source IP address of the SIP call?
Yes, that's one transport identifier. Yes, yeah.
And that IP address is allocated to the mobile device after its pass point association.
Yes.
Correct?
Yes.
Okay.
Yes.
So in that case, I think if the pass point association is an emergency use only network, it's appropriate then to advertise location for those IP addresses, because that should only be handed out to people who need to make emergency calls. So that's fair. In that case, I think you can use RFC 8805, right, which is self-published geofeeds.
Right.
And so as long as you have text that says there's privacy exposure here, but this is overridden by the fact that this is an emergency call, and these IP addresses should only be allocated to devices that are using this passpoint profile to make an emergency call. And I think you could maybe get around the privacy concerns that way, right?
Oh, that's a great suggestion.
Yeah. So then just say your SIP provider just has to have these IP addresses published in an RFC 8805 format. You then have another control plane problem of how to discover those, but at least that information can be published on a provider by provider basis.
No, it makes absolute sense. Yeah. Thank you so much.
And still thinking about how to help you do this somewhere. But Elliot might be a good call.
Thank you so much. Suresh.
Thank you. Suresh Krishnan. So for TNG, right, like I think the working group, there is a working group that should be doing this. It's not doing it, right? The working group is ECRIT, E-C-R-I-T. That is the right working group to do it, except that they're totally inactive and they have not done their job, like if I can say that. So that is a group that's like maybe AD sponsor would be an option, like to do it other than like talking to Eric.
They've gone quiet.
Okay, like if you strike it from the record, but yes, they've been quiet. Yes, is probably the right group to get the right set of review, because they have the expertise for the emergency calling, because that is their goal. I think that would be a good group to get review from, no matter what publication venue you want to pursue.
Yeah. Thank you, Suresh. Okay. Thank you so much. Yeah, I think one last comment is, I think, next IETF probably will do a hackathon around this and some passpoint profile testing around this. Maybe we'll sync up later. Yeah, thank you so much. Yeah, next. I think there's the last presentation we have. End marker. Jeffrey, yeah.
So this is a late entry into the agenda. It's about an end marker in the data networks when we use distributed UPF or in the end up in that earlier proposal. I'm sorry that I forgot to put my co-author's name here as well. TNG and the macro. Yeah. Next slide, please.
So Jeffrey, if I took any of your time, my apologies. I didn't check my time. Yeah.
That's fine. That's fine. The quick background on end marker. We have a UPF here with 2 GNOBs, and the UE is moving from GNOB 1 to GNOB 2. So when that move happens, the UPF establish a new GTP tunnel to the GNOB 2 to start sending the downlink traffic towards GNOB 2. At this time, it also sends the end marker on the old tunnel to GNOB 1. And then GNOB 1 will finish sending its in-flight traffic for the UE toward, and then it forwards that end marker to GNOB 2. When before the GNOB 2 gets that end marker, it will hold the data that it was receiving from the UPF. And when it received the end marker, GNOB2 will release the data. This is to ensure the package is delivered in order. Next slide. Now, if we are using distributed UPF, then this end marker mechanism is not enough. Typically, the UPFs are centrally deployed, but for edge computing purposes where the low latency is required, we either use UL cell UPFs together with central UPFs, or we just completely distribute the UPFs. And as shown in this picture, where we have the UPF1 and UPF2 distributed. And then when you have distributed UPF, then the data network is also distributed. And in that case, those different data network locations will be connected with VPN. So here we have PEs connecting those local data network sites. Now, in this scenario, the hub PE will connect to the central data network, and other PEs, P1 and P2, those are not 5GS functions. They don't do any those end marker kind of things at all. So in these scenarios, we may still have excuse me, packet reordering issue. Next slide, please. So now, if the UE moves from GNOB1 to GNOB4, where GNOB4 is attached to the UPF2, in this case, there are two issues that we may want to address. One is the address continuity that Marco mentioned earlier. Some people say that it's not really a problem that we need to care. On the other hand, if you have an Ethernet PTU, then you do have persistent MAC addresses, and you do still have the same problem. And then the packet reordering. So these two are actually sort of related. So to support persistent addresses, one way to do is that those UPFs, they were advertised per UE routes. In this example, the hub PE will maintain all the per UE routes, but it only advertises an aggregate route towards the outside world. Other PEs, for example, PE1 and PE2, they do not need to hold those per UE routes. They just need a default route towards the hub PE. Or they can optionally keep those per UE routes for optimal data forwarding. Now, in this case, let's say we have traffic from the central DN to the UE. The moment that hub PE learns that the UE is now moved to UPF2 because UPF2 advertises a per UE route, you will switch traffic to UPF2, but there could still be in-flight traffic towards UPF1, and then the packet reordering can happen. Because those PEs are not the 5GS functions, we cannot use an end marker to address the packet ordering issue. And this draft talks about one way to address that problem. Next slide, please. So basically, actually, please go back to the earlier slide. I'll just talk about it in this picture. So the moment the hub PE installs the per UE routes so that it sends traffic towards PE2, it will send the ICMP message towards UPF1. That ICMP message is basically a trigger for UPF1 to send an end marker. So the UPF1 gets that end marker trigger. It will send the end marker towards GNOB1. GNOB1 will forward it to GNOB4. And so the GNOB4 will hold the traffic that it receives the hub PE before it receives that end marker that is forwarded by GNOB1. Next slide, please. So this is the basic solution. You can skip to the next slide. So we do have some questions to ask ourselves and ask our operators. How important is the end marker mechanism nowadays? Because the mobile network is getting faster and faster, that you may not be able to hold to buffer too many data anyway. And besides, the IP network is not to guarantee the traffic ordering or traffic loss, even though we try our best to do it.
So if I may comment on that. So anytime there's a buffering, reordering is an issue, right?
Right. That is one thing that we do want to get answer. Another thing is people may ask that if you need a hub router to initiate the end marker process, why bother with just using UPFs? Just use the ULCL UPF. So for that, I have some slides answering those questions, including some slides about UE to UE traffic where you do not need a hub PE and how we handle those situations. There are all those slides talking about that in the draft and in the slide deck. I don't think I'm going to finish all those slides here. I just want to bring this up because this is actually the draft published a year ago. I never presented it. Today, I wanted to bring it out and let people know that this exists. So please take a look at the draft and the slides and think about whether this is a problem that we want to solve and whether the solution is good, things like that. So I think with that, I'll just end my presentation here.
Thank you so much. Any questions, comments? John?
A very quick comment. As we heard just before, if you're introducing buffering and delays, then of course the end marker would be needed. But equally, the statement that you made earlier that networks are getting faster and faster, so you're essentially going to make the problem sometimes worse by buffering this up. I wonder if we should also consider, the other advancements like multipath TCP and actually parallel connections that will not introduce this kind of a bottleneck in the middle. So I don't know the answer to this, but it's just a thought.
Yeah, one thing about multipath TCP is that that may work for the IP scenario, but 5G also support Ethernet PDU, and that is something that's we still need to handle because Ethernet PDU you basically have persistent MAC addresses no matter how you do it.
Right. I think my comment would be if you do something in IETF, let's generalize it to make it access agnostic, right? Find a bit more use cases than if you solve it here, that will be perfect. That way, we can take it to 3GPP and say, yeah, this is generic spec, use this mechanism, right? If you limit to 3GPP, we'll have a problem. I think that's the way I look at it. I think we should generalize it maybe in Wi-Fi systems also in Wi-Fi 7, 8. The same scenarios are applicable, so maybe we should think broadly, yeah.
Just a quick comment. So I think it's similar directions as we had for mobile traffic steering, right? Which network we see on the mobile side, and here we move a problem that has been solved in the 3GPP access network towards N6, right? So I think when people see about forwarding and buffering, so they think about buffer bloat, and we are not talking about G node Bs, but about routers and UPF functions. So this kind of UPF or UPA to UPA kind of relocation. The question is if we look at more advanced scenarios, so if that maybe nodes that are not static in the topology, like satellites, for example, which may have a base station plus a UPF, so referring to the end of kind of scenarios. So if we don't have user mobility, but actually UPF mobility, we have the same problem here. So maybe we can at least touch these kind of advanced use cases to see if end marker concept may make sense in such a kind of deployment.
Yeah, very quick clarification. The buffering does not happen on the router. It still happens on the G node beads. We're basically just using a new mechanism to trigger the end marker process.
Okay.
Okay, thank you, everyone. I think we need to, we are slightly 4 minutes over. Thank you so much. And my apologies, I took a couple of minutes of your time. Okay, thank you so much, everyone. With this, we wrap up the call. Yeah.
Yep.
Thank you.
Thank you.
Thank you so much. Yeah. See you in Dublin.
Yep.